In this video, we're going to learn about acids and bases. We're going to start off by taking a look at what acids are, and then afterwards we'll go into bases. So an acid is a chemical, it's a substance that will increase the concentration or the amount of hydronium ions in solution. What that means is when you basically put it in water, it'll increase the amount of this special type of ion called hydronium. And hydronium can be represented like this, H3O+, but we often abbreviate it as H+. So let me show you how that works. This here is a generic acid. It basically just means like a made-up acid with a general formula to show you what an acid might look like, but nothing specific. So when you put that into water, it'll sort of break apart, not really decompose, but separate into the ions it's made up of. And the ions that it's made up of are H+ and A-. And notice that this H+ here is the hydronium, the H3O+, which again we abbreviate as H+. So if a substance, when you put it in water, increases the H+ in the water, then it's considered an acid. So generally speaking, if a substance contains H+, then you know you're dealing with an acid. For example, hydroiodic acid is HiAQ. Sulfuric acid is H2SO4, We have the H+ here. We have the H+ over here, okay? So here you can see we have HCl. When we put it in water, the HCl separates into H+ and Cl-, and because we're increasing the amount of H+ in the water, that makes HCl an acid. So an acid is a substance that increases the H+ or hydronium ion concentrations in solutions. In concentrations, you can think of it just as meaning like the amount for now, even though it's not quite that. Just for now, think of it that way. So we often say that when we put an acid in water, when it dissolves, it ionizes. Ionizes essentially means that it turns into its ions. It separates or turns into its ions. In reality, the acid doesn't really exist as ions until you put it in water. That's why we say ionizes. It's like transforming into ions. So if we have HCl, AQ, that means we put it into water, and we want to show that ionization equation, we simply write HClAQ, put an arrow, and then separate it into the H+, which is really H3O+, plus the other ion, Cl-, and the charge comes from the periodic table for that. So that there is the ionization of hydrochloric acid. And so we've increased the amount of H+, which makes that an acid. So in acidic solutions, you have more H+, then you have this other ion called hydroxide. So if your solution is acidic, you'll have more H+ compared to hydroxide. How do you make acids? If you want to make acids, you could take a non-metal oxide, you could react it with water, and that would make an acid. It's a special type of synthesis reaction, right? We take carbon dioxide, for example, which is a non-metal oxide, non-metal with oxygen. You mix it with water, and that will produce carbonic acid over here. You can see the H+ in the front there. So that's how you would synthesize acids. Now, a base, on the other hand, that's a substance that instead of increasing the H+, it increases the OH-, the hydroxide, in water. So generally speaking, you know you have a base if you see OH-, CO32-, or HCO3-. So things like sodium hydroxide, sodium carbonate, those are considered bases. And the reason these are considered bases is because they do help to increase the OH- in other ways. You don't really need to know what other ways those are right now, but just get that if you see hydroxides, carbonates, or bicarbonates, that those compounds would be considered basic. One more compound you should memorize as being considered basic is ammonia, NH3. It does not look like it should be basic, but it is, and I'll show you why in just a bit, but ammonia is considered basic. So here we can see a base, NaOH. When you put it in water, it separates into the Na+ and to the OH- ions. And so this is what makes it basic. So you can see here we have NaOH, put it in water, separates in the Na plus, but also the OH minus, which is what makes that solution basic. So when we put a base in water, we write it kind of the same way as we did with acid. You put the base, aqueous, arrow, but instead of saying ionize, we say dissociates. It's very similar, but it's a different terminology for a reason. The acid, you'll notice HCl is a molecular compound, covalent, meaning there are technically no ions there. But then when you put it into water, ions are generated, they're created, and that's how we say ionize. Whereas in the base is already ionic. There's already ions there. They're just not separated yet. So when you put it in water, they separate, and that's called dissociation. Similar process though. So you'd separate it like this. You'd put the Na plus that comes from the periodic table, AQ, plus the OH, which is OH minus, AQ. And it's that OH that makes the solution basic. In basic solutions, you have greater concentrations of OH compared to H plus. How do you make a base? Very similar to how you make an acid, except instead of a non-metal oxide, it's a metal oxide in water in a special synthesis that makes a base. So Na2O, that's a metal oxide, and water over here, it'll create NaOH, just a crisscross between the metal and hydroxide, just like that. Now, you can have solutions that are neither acidic and neither basic, and you can probably already guess how the concentrations of H plus and OH compare in those. So in acidic, H plus wins. In basic, OH minus wins. But in neutral, H plus and OH minus are actually equal to each other. So salts are usually neutral. Water is considered neutral. And water is very easy to understand because water here is HOH. It's one H plus and one OH minus, which is why it's neutral. So here you can see the images of acidic, neutral, and basic solutions. Acidic, you can clearly see H plus is a winner. Basic, you can clearly see OH minus is a winner. However, neutral, you can see that you have equal amounts of the OH and the H plus. Here we can see the acid ionizing into H plus and the anion when you put it into water. Here we can see a base dissociating into OH minus and the cation when you put it in water. So far what we've seen are what acids and bases are. We've seen how their solutions compare to each other in terms of the H plus and the OH minus. We've also seen where the neutral solution is. Part of your task will be to go through the videos in your handout. So there's a video here, and in that same video, you can also just click here. You'll learn about examples of acids and bases. So here you'll have a list of acids and bases, and you'll have to go and classify these as either acid or a base. You'll have to write out its formula based on what's shown in the video, or based on the nomenclature and formula lesson you've done already. And then you're going to write down some of the uses of that acid or base. Over here in this table, you're going to, in the video, compare the properties of acids and bases to each other, okay, because there are clear differences. So you do need to know those differences in property. And you're basically just going to kind of fill in some blanks of the differences of properties between acids and bases. So for example, you're going to see that for taste, and we don't taste in the lab, but a long time ago, they used to taste things to figure out if you're dealing with acid or base. Acids are usually sour, and bases are usually bitter. For acids, in terms of their touch or their texture, again, typically you would not touch acids or bases in the lab, but acids, they don't really have a characteristic texture, whereas bases, they feel soapy, very slippery, almost like touching soap. Soapy or slippery. They also differ in terms of their indicator tests. So indicators are chemicals that change color when you put them into different chemicals. Phenolphthalein is a special indicator. It's actually colorless in acids, but when you put it in a base, it turns pink, and we've seen that in demos before. Another indicator is called litmus. There's two types of litmus. There's blue and there's red. If you have blue litmus and you put it into an acid, it becomes red. If you have red litmus and you put it into a base, it becomes blue. For the conductivity, Both of them are actually electrolytes, which means they conduct electricity in solution because they have ions. pH, that's important to know because we'll be seeing pH later on. The pH is less than 7. And then the base, pH is more than 7 for a base. And then for neutral, you probably guessed it, pH is equal to 7. Other properties that you'll learn about in the video as well is that acids, they'll neutralize bases, they'll react with carbonates, and they'll react with metals to make H2. Bases will neutralize acids. They generally do not react too much with metals. And then you'll also see the ion production. So remember that your acids generate H plus, or you could say H3O plus, whereas bases generate OH minus in solution. So that's all the stuff you'll learn about within those videos. Please make sure you watch that. Make sure you know examples of acids and bases and practical applications, and make sure you know the properties of acids and bases well. Before we go on to the next video, I just want to show you quickly why ammonia is considered a base, even though there's no OH. And I'm going to draw a Lewis structure to show you how this works out. So here we have ammonia, NH3. When you put it in water, what's going to happen is the electrons here are sort of attracted to the hydrogen here because the hydrogen is positive. And so that's going to produce some NH4 plus what's left behind when you remove the H is OH minus. So you'll notice that it increased the amount of OH minus in solution, which is why NH3 is basic. In the next video, we're going to take a look at the pH scale, what that means, along with indicators.